So we've been talking about deviations, right? But the deviation is the average deviation from the mean, which is what our standard deviation finds. And so it finds on average how much do I deviate. It's sort of the plus minus. Most scores, right, typically it's around 68% of the scores land one deviation away. So between adding my deviation and subtracting my deviation. Almost all of the scores land between two standard deviations. If I added my deviation twice or subtracted my deviation twice, almost all scores will land between two standard deviations. Alright, so we're going to look at the finding the sample and the population standard deviation giving relative frequency tables, because we do have to plug them into the calculator a little different. Right? But basically it's the same song and dance that we've been doing. We actually found them, we just didn't know we found them before when we were doing mean. So I'm going to go back to the employee person, and again, remember, it's different when it's sample than when it's population. And the problem will always tell you, and it should make sense in the sample and the population case. And so this one says, find the sample standard deviation, and it matters. Right, so it's important. And it should make sense, since it's a sample. We surveyed 120 unemployed people. Right? There's more than 120 unemployed people in the world. Right? That's a small sample, actually, of the unemployed people. And so it's a sample where we found number of years of high school and how many people answered that way. So remember, this is the frequency table way before. Number of years of high school are the X values. Frequency, or how many of those X values. So 6 people answered 0 years of high school. 24 people answered 1 year of high school. 39 people answered 2 years, and so on. Alright, so that's the tally of how many people gave that answer. And so remember, when we go to the stats key, list 1 are always the X values, list 2 are always the frequencies. So that's what we're going to do again. We're going to go to this is statistics, we're going to go to stat, we're going to edit, clear any list out you have. List 1 are your X values, which are your years of high school. List 2 is always your frequency. And so I go to the calculator, go to stats, edits. I don't have anything in my list, but if I did, I'd have to clear them out. Alright, so now I'm going to carefully type in my list. So 0 for 1, 2, 3, 4 for the years of high school. That goes in list 1. In list 2, 6, 24, 39, 30, and 21. Let me do a quick glance, make sure I typed them right. 0, 1, 2, 3, 4, 6, 24, 39, 30, and 21. Alright, quick. Do your one variable statistics. Alright, now remember, I plugged in 2 lists. And so if yours is a calculator that's like mine, I have to tell the frequency list is list 2, and so that's second 2, that puts list 2 in, and then I'm ready to calculate. If yours is an older version, you will have it home on your screen. It'll show up one variable stats on your home screen. You have to tell it list 1, comma, list 2. If you don't do that, it'll only use the first list. It'll just take the average of the numbers 0 through 4. You don't want the average of the numbers 0 through 4 because you've got 6 zeros, 24 ones, 39 twos, 33s, and so you want to make sure you have the frequency. So you have to tell it that, and so again, make sure you're careful. The comma, in case you've forgotten, is above the 7. The list 1 is second the 1 key, the list 2 is second the 2 key. And then you should hit enter, and it should give you this information. And my mean was 2.3, which we found before, and again, the deviation is small. I want the sample deviation, and I actually have to go out to the 3rd decimal place before it's different between population and sample. And so this would probably be a problem where they tell you to round 4 decimal places. And then you have to make sure you pick the right one. We're picking the S for sample, so it's the 1.1272, not the other one. Alright, so the sample, and I put sample standard deviation, which is 1.12, and I've forgotten already, 272. Alright, so the average was 2.3 years of high school. The plus minus on that was 1.1272. So most people were within just slightly more of 1 year of that, the answers. And it was. This would then range, if I were kind of just rounding the whole number, this would range between 1 and 3, right? Most of the people answered between 1 and 3. Right? That's where most of the people were there. Few people answered at 0, few people answered at 4, but those were the smaller groups. Alright, so again, careful with the sample. Careful with typing it in. Careful with your... Again, there's a lot of little things you have to remember. A lot of little things that could give you the wrong answer. Alright, the next example. The table below gives the height in inches of each member of a women's college basketball team. The data is given in brackets. Because again, when you do heights, most people have a different height if you can go down to the, the small decimal. Use the midpoints. So I've got to use midpoints. Find the mean, and it's the population. It should be the population because I measured every single member of the basketball team. I didn't take a sample of the basketball team. I measured everybody. But it does tell you. Find the population. Makes sense, though. Find the population standard deviation. All right, so before I can get there, though, I have to find the midpoints, right? My height would be my x values, but I can't plug in a range 66 to 69. This would be my frequencies, which would be my, again, list 2 frequencies. But before I get to the frequencies, I have to find my midpoints. Alright, so remember, the midpoints is the average between the high and the low, and so that should have been equal to on these. For some reason I lost my equal to. It should be on yours, though. It was on the other side. So the midpoint is I take the high value and the low value in the range and divide by 2. So the first one would be 66 plus 69 divided by 2. So the first midpoint would be 67.5. The next midpoint would be between 69 and 72. So 69 plus 72 divided by 2 comes out 70 and a half. The next midpoint would be between 72 and 75. And so that comes out 73 and a half. And then the last one between 75 and 78, which comes out 76 and a half. Alright, so those are my x values. That goes in list 1. These are my frequencies. They go in list 2. Alright, so frequencies are the number of people. That's how often. 3 people are in the first category. So 3 people I'm saying are at 67 and a half inches. 6 people are in the second category. So I'm saying 6 people are at 70 and a half inches. 4 people, again, so on and so forth. And so this is list 1, midpoints, frequencies in list 2. So I go to my calculator and I plug them in. So I'm going to clear. So stat, edit, clear out my list first, and then type my new list in. So first, it's list 1, which are the midpoints. That's the 67 and a half. 67 and a half, 70 and a half, 73 and a half, and 76 and a half. Right, then it's the frequency. How many people land in those groups? The first one is 3, 6, 4, and 1. Let me double check myself, make sure I typed them in right. I believe I did. Quit. Go back to stats, go over to one variable statistics. Again, I should be good. List 1, list 2. So if yours isn't not like mine, though, you have to tell it list 1, comma, list 2. So if yours is a different calculator, you have to tell the comma thing. Right, hit enter, and it should give you, so the average was 71. So on average, the height of a basketball player on this team was 71.4 inches. It's a population. So population is the, and again, the way you kind of think of it, sample S, population, there's kind of O, sigma's kind of like an O. So you want the 2.58. The 2.58 is the one you're looking at. Alright, so my answer, the average, it actually asks for both. So the average height is 71.14 inches with a standard deviation 2.58. Make sure I get the again. Sigma is the one we're looking for. The population standard deviation. And so with a deviation of 2.58. And so most people on the team land between the plus minus of that. Right? So if I added and subtracted that deviation, that's the plus minus. So most people on the team have a height of 71 inches plus 2.58 or a height of 71 inches minus 2.58. They land in that range. Most of the people on the basketball team. Alright, so that's relative frequency tables, population, and sample standard deviation. I'm going to stop there. Next one we're going to get to is probability cases.